it's in the center there. However, the way they made it, they left a hole through the center, so the radiation goes through that ball bearing. And it's not a full ball bearing, it's just a portion of a ball bearing, because a whole ball bearing would be too heavy. And because you're flying, everything needs to be lightweighted. So, but there is in the center there a precision ball bearing and the way the whole thing works is that you put it under oil pressure. So it's a hydrostatic ball bearing, and there's pressure, about 20 atmospheres of pressure pushing on the oil, so it literally floats on oil that's under pressure.
The disc that the man is standing next to down at the bottom, where it shows he's 6 feet, no, down on the bottom,
yeah,
right there.
Yeah, that's the diameter of the mirror.
Oh.
So that's how big the mirror is, this mirror here.
Oh.
This mirror, by the way, has been lightweighted. It is like any other telescope mirror that you've seen. It's made out of ceramic. It's called Zero-Dur. No, it's is it Zero-Dur? Yeah.
Zero-Dur.
Yeah, I got it right.
You got it.
Yeah. There's a. Anyway, it's
He's
Zero-Dur.
your prompter, huh?
Pardon?
He's your prompter.
This is here, and he's going to be showing us the lab. And but there's a U.S. company that has a competitor stuff, but the Zero-Dur doesn't expand or contract under changing
now,
temperature.
Can you stand on that mirror when you go through that chamber? Can you stand on that number one?
No. You cannot stand on
Where
this.
are you?
When you go into the chamber, you just stand down here.
Oh.
And there is a cover that goes on here, but I'm not even sure people.
Is that like a clean room?
This is all clean. Yes, it is. I don't know. It's 10,000 or 100,000. It's. You know what it is supposed to be in there?
Supposed to be 10.
10,000. Yeah. But it's kept clean because now, of course, when you open up in the stratosphere, there's still some stuff. Although, actually, I think it gets clean because the wind goes in and throws out some stuff. But we just cleaned the mirrors, and it's a lot better, and it's good to keep cleaning. So we do mainly infrared, and this is the visible here, and that's the rainbow, that small part. We actually work over a much larger region than the visible in the infrared. There's a huge area in the infrared, and the sky looks completely different in the infrared. This is the Orion Nebula in the visible. This is what it looks like in the infrared. This is all heated dust, and that's actually what we want to go after, is heated dust, heated molecules. When we use the radio techniques, we're looking for molecules, and molecules that you can't see.
You're looking for a little guy out there waving back at you, right?
Well, we could, if he waves back, we could do that as well. Now here's why we fly on SOFIA. This chart here is the most important. So come up a little closer if you can't see this. This is the infrared. The visible is actually over here.
Thank you.
And this is what you get on Mauna Kea. Blue means there's nothing going through. So there's some windows at Mauna Kea. There's one at 10 microns. That's what keeps the Earth cold.
Yeah.
And then after a while, there's nothing at all that goes through. But if you go up into the stratosphere with SOFIA, it basically just opens up. So that's why we do SOFIA, is to get. So you can think of it as being cloudy all the time down here on Earth, and you've got to get up above the clouds, and that's what we do.